On numbers 1 through 4, it says calculate the following logarithms, and it says you do not have to check your answer. So all you're doing is, on number 1, you're asking 5 to what power equals 625. So you're going to plug in different numbers as an exponent on 5 until you get 625. You should get 4 as your answer on number 1. Number 2, this logarithm is asking 2 to what power equals 1/8. If you raise a whole number to a power and you end up with a fraction, that means your exponent needs to be negative. So I would suggest starting with -2. If you don't know what that is as a fraction, we can change it to a fraction. It's not 1/8, it's 1/4. So now I'm going to try -3. Math, enter, changes it to a fraction. That is 1/8. So we need our exponent to be -3, which means the answer on number 2 is -3. Number 3, log base 10 of 1,000. So 10 to what power equals 1,000? You should get 3. And number 4, log base 27 of 3. So this time it's asking 27 to what power equals 3. So when you raise a whole number to a power and you end up with a smaller whole number, that means your exponent should be a fraction. So starting with 27, I'm going to raise it to the 1/2 power. That's not it. Then we try 1/3. That is it. So the answer to number 4 is 1/3. If 1/3 didn't work, then you would go on to 1/4, 1/5, and so on. The numerator of your fraction is always going to be 1. Questions on those 4? There's not really any work to be shown on these 4, just an answer is fine. Next 4 problems, you're just converting between exponential and logarithmic form. You do not have to solve anything. You can use the loop trick to change between forms. On number 5, if we start at the base, which is 3, we draw a loop around to t. That means when we change this to log form, first of all, we need to write log, and then we can follow our loop. So it's log base 3 of s equals t. So again, on these, there's not that much work to be shown. Number 6, we're changing from log form to exponential form. Again, start at the base, which in this case is a. Draw a counterclockwise loop around to b. So when we write this in exponential form, we follow our loop. A to the power of c equals b. Number 7, changing from exponential form to log form. So we've got log base h of 12 equals k. And number 8, changing this logarithm to exponential form. 5 to the x power equals w. Questions on this section? Okay, let's move on. The next set of problems says use the properties of logarithms to solve the following equations. Show all of your work. Check your answers only if you find more than one value for the given variable. So only if you find more than one value for x do you have to check it. Number 9, we have a logarithm on one side with just a number on the other. So to be able to solve this, we need to change to exponential form, just the same way that we did in the last section of problems. So this becomes 3 squared equals 2x minus 1. 3 squared is 9. So 9 equals 2x minus 1. And now we're just solving for x. So to get x by itself, we need to get rid of this minus 1 first. So we're going to add 1 to both sides. 10 equals 2x. Divide both sides by 2. 10 divided by 2 is 5. These 2's cancel. So we end up with x equals 5. We don't have to check this because we only got one value for x. Okay, let's move on. Number 10. On number 10, we're starting with a logarithm equal to another logarithm. So as long as they have the same base, which they do, they both have a base of 5, that means we can set x plus 5 equal to 4x minus 1. In order for these logarithms to be equal, those two things have to be equal. So that's how we're going to solve for x here. Set x plus 5 equal to 4x minus 1. Okay, so now we need to get all of the terms that have an x on one side and everything else to the other side. So I'm going to start by subtracting this x from both sides. There's other ways that you can work this. If you worked it differently than this, that's fine. Just check it to make sure you get the right answer at the end. So that leaves us with 5 on this side. 4x minus x is 3x minus 1. Okay, now we've got all of our x's on the same side. So we need to start solving for this x. So I'm going to add 1 to both sides. 6 equals 3x. Divide both sides by 3. And we get x equals 2. So again, we don't have to check. We only got one value for x. Okay, number 11. We have log base 4 of x plus log base 4 of x plus 6 equals 2. So when you're adding two logarithms together, we can combine these into one logarithm. When we do that, the base stays the same, so it's still log base 4. But then we take x and x plus 6 and we multiply. So x times x plus 6. Okay, now we're to the point where we have one logarithm on one side with just a number on the other side. So just like on number 9, we're going to change this to exponential form. So we get 4 squared equals x times x plus 6. Four squared is 16. X times x plus 6, we need to distribute the x. So we get x squared plus 6x. Okay, now we've gotten rid of the logarithms. We don't just have an x that we can solve for. We have an x squared and an x. That should tell you that you're going to have to end up factoring in order to solve this. So to be able to factor, we need everything on one side of the equal sign with it set equal to 0. So I'm going to subtract 16 from both sides. So get 0 equals x squared plus 6x minus 16. To factor, you're looking for two numbers that multiply to be 16 and add to be 6. So factors of 16 would be 1 and 16, 2 and 8, 4 and 4. Now it needs to multiply to be negative 16, but it also needs to add to be positive 6. So if we use 2 and 8, we keep the 8 positive and make the 2 negative. Those would multiply to be negative 16. They would also add to be positive 6. So our factors are x minus 2 and x plus 8. Okay, this scratch work that I did was to find the factors. These are not your answers. They just go in the parentheses with the x's. Now to find the solutions, we set each factor equal to 0 separately. So x minus 2 equals 0, x plus 8 equals 0. Solve for x in both of these equations, and we get x equals positive 2 and x equals negative 8. So on this one, we have to go back and check our answers. Because we got more than one answer for x, we need to check to see which ones of these are solutions. So we're going to go all the way back to the very first line of the problem and plug in each of these x values separately. So let's start with x equals 2. We've got log base 4 of 2 plus log base 4 of 2 plus 6 equals 2. Before you go any further, you need to make sure that there's not going to be negative numbers inside of a logarithm. Right now we have a positive 2 and what's going to come out to be a positive 8. So we don't have to worry about negatives here. That means we can continue to check. When we do that, we're basically following the same steps that we took when we solved. So combine these two logarithms into one. So it stays log base 4. And then we multiply 2 times 2 plus 6, which is 8. I'm going to go ahead and change it to 8. Change to exponential form. We get 4 squared equals 2 times 8. Four squared is 16. 2 times 8 is 16. So x equals 2 is a solution. Circle it, box it up, however you want to. Just show that you have checked it and that you know that it is a solution. Okay, that doesn't automatically mean that we get to say negative 8 is not a solution. It could be that they're both solutions. It's not that there's going to be one solution and one that's not every time. So we do still need to check negative 8. So again, we're going back to the very first line of the problem. We're going to plug in negative 8 for x. Before we continue checking, we have to make sure that there's no negatives where we're not allowed to have a negative. Right here we have a negative 8. And right here we have negative 8 plus 6, which is going to be a negative 2. So for those reasons, we cannot continue to check this. We go ahead and cross negative 8 out as a solution. So on your semester test, I would prefer to see that you actually tried to plug in that number, saw that it was not going to work because of the negative numbers, then cross it out. I don't want you to just cross it out without showing me that you actually tried plugging it in, because then you could have just crossed it out because you're thinking, okay, this one's a solution, so this one's not, but that's not always true. I want to know that you know that it could be a solution, but when you go to check it, because of those negative numbers, then you can say it's not a solution. Any questions so far? Pretty good. Okay, let's keep going. Number 12. Number 12, we have two logarithms that are being subtracted. So we want to combine those into one logarithm. Because they have the same base, we can do that. And when we combine them, that base is going to stay the same. So it stays log base 4. But this time, since we're subtracting, instead of multiplying these numbers, we will divide. So we will divide 91 divided by x. And that's still equal to log base 4 of 13. Now we have something that looks similar to number 10. A logarithm set equal to another logarithm, and they have the same base, which means we can set this fraction equal to 13 in order to solve. So 91 divided by x equals 13. Okay, we want to get x by itself, so we need to get rid of this fraction. To get rid of a fraction, you multiply both sides by the denominator. So these x's will cancel and just leave us with 91. 13 times x is 13x. Now to get x by itself, we need to divide both sides by 13. 91 divided by 13 is 7. So our answer on number 12, x equals 7. All right, let's move on to number 13. We have a new set of instructions. It says solve each system of equations by substitution. Show your work and write your solution as an ordered pair. So there are different ways to work this by substitution. So if you didn't work it this exact way, that's fine. But as long as you worked it by substitution and not elimination, you're good. If you worked it by a different method other than substitution, I will count off. Okay, so substitution means we solve one of these equations for one of the variables. Lucky for us, this one's already solved for y. Y equals 2x. So instead of y in this equation, we can plug in 2x because they're equivalent. So we're substituting 2x into y in this equation. We get 4x plus 2x equals 6. So now we can solve for x in this equation. 4x plus 2x is 6x. Divide both sides by 6 to get x by itself. We get x equals 1. We can take that value for x, plug it back into this equation that's already solved for y. So y equals 2 times 1, which is 2. Okay, the instructions asked us to write this solution as an ordered pair. So an ordered pair, the x value comes first, then y. There's our answer. Number 14, still solving by substitution. So we need to solve for one of the variables in either one of these equations. It's not, nothing is solved for us like it was in number 13. So what I do is I find the variable that has a coefficient of 1. This variable right here, x, in the second equation. It's going to be easiest to solve for that x. So if I want to solve for x in this equation, I need to subtract 2y from both sides. So we get x equals 7 minus 2y. Now that I have an equation solved for one of the variables, I can substitute that into the other equation. So instead of this x right here, I can plug in 7 minus 2y because that's what x is equal to. So instead of 4x, we have 4 times 7 minus 2y. Then minus 5y equals negative 11. So all I did was replace x with what x is equal to. Now I should be able to solve this equation for y. So let's get rid of these parentheses by distributing the 4. 4 times 7 is 28. 4 times negative 2 is negative 8. Then we can combine like terms. Negative 8y minus 5y is negative 13y. So we've got 28 minus 13y equals negative 11. We're trying to get y by itself. So I want to get rid of this 28. I'm going to subtract 28 from both sides. '28's cancel and leave us with negative 13y. Negative 11 minus 28 is negative 39. Then divide both sides by negative 13 to get y by itself. Negative 39 divided by negative 13 is positive 3. We can take that value for y, plug it back into this equation that we already solved for x. So x equals 7 minus 2 times 3. Two times 3 is 6, and 7 minus 6 is 1. So our solution has an ordered pair. X value is 1, y value is 3. Numbers 15 and 16, now we are solving the system by elimination. So again, there's multiple ways to do this. As long as you have solved it by elimination, you're good. Okay, on number 15, We need to choose whether we want to get rid of the x variable or the y variable. It's going to be about the same difficulty no matter which one you did. I usually go with the smaller numbers, so only because y has the smaller coefficients, I would choose to get rid of y. Getting rid of the x is perfectly fine too. So if I want to get rid of the y variable, right now we have a +3 and a +2. So a common multiple would be 6. So if I make them both have a coefficient of 6, as long as one of them is negative, then they will cancel out. +6 and a -6 would cancel. So if I multiply this first equation by 2, that's going to give me a +6y. That means I need to multiply the second equation by -3, so that would give me a -6y. Okay, so if we do that, the first equation by 2, that means multiply everything in that equation by 2. 8x plus 6y equals 2. Multiply the second equation by -3. We get -9x minus 6y equals -6. So after you've made sure that something will cancel, now we can combine these equations. 8 plus -9, which is the same as 8 minus 9, we get -x. +6y and -6y cancel. 2 plus -6 or 2 minus 6 is -4. We need to make sure our variables are positive. So we need to divide both sides by -1. Gives us a +x equals +4. Once you get one variable, you can go back to either one of the original equations, plug that value in for that variable. So if I just use this second equation, instead of 3x, I'm going to have 3 times 4 plus 2y equals 2. 3 times 4 is 12. Subtract 12 from both sides. So now I'm solving for y. We get 2y equals -10. Divide both sides by 2 to get the y by itself. Get y equals -5. So the solution on number 15 is 4, -5. So on this one, on number 15, we had to multiply both of the equations by something in order to make a variable be eliminated. That's not always the case. Sometimes you only have to multiply one of the equations by something, like in number 16. Again, I'm looking at the smaller coefficients, which in this case would be on the y variable, 4 and 2, instead of the 8 and 4 that are on the x's. And I'm also looking, it's a good thing when you already have opposite signs. So like the y variables, we have a +4 and a -2. So even though they're not the same number, at least they're already opposite signs. So if we were to multiply this second equation by 2, that would give us a -4y that would end up canceling with this +4y. So in my opinion, that's the easiest route to take. That's not the only route to take, but that's what I'm going to do. So if we multiply everything in this equation by 2, I'm going to go ahead and write it just below this one. So we get 8x minus 4y equals 4. So now that I've made sure that something will cancel, I can combine my equations. 8 plus 8 is 16x. The y's cancel. 0 plus 4 is 4. Now we solve for x by dividing both sides by 16. So we get x equals 4 divided by 16, which is 1/4. If you put 0.25, that's fine. I prefer fractions, but I won't count off, especially for if it's a fraction like 1/4, where it's really easy to write it as a decimal. If it's 1/3 and you change it to 0.33, I don't like that as much because it's supposed to be 0.3 repeating. It's just easier to leave it as 1/3. Basically, what I'm saying is, as long as you've done the work correctly, your answer is in a different form than what I have, I probably won't count off. I'm looking to make sure you know how to get to that point. Okay, so let's plug that value in for x. In either one of the original equations, I'll just use this second one. So instead of x right here, we've got 1/4. Four times 1/4 is 1. So we're trying to get y by itself. I'm going to get rid of that 1. Subtract 1 from both sides. We get negative 2y equals 1. Divide both sides by negative 2. We get y equals negative 1/2. Again, negative 0.5 is fine too. So our solution, 1/4, negative 1/2. Okay, this next section, our instructions say perform each matrix operation. So to add these two matrices together, all you're doing is adding corresponding elements. So our answer will be another 2 by 2 matrix. We've got 5 plus negative 4 is positive 1. Negative 6 plus 6 is 0. 8 plus 8 is 16. And 9 plus negative 3 is 6. That's our answer. The next one, our answer will be a 3 by 1 matrix, just like these two. And we're adding again. So 2 plus negative 6 is negative 4. 5 plus 3 is 8. And 8 plus 12 is 20. Number 19, this time we are subtracting. Negative 5 minus negative 3, that's the same as negative 5 plus 3, which is negative 2. 6 minus 2 is 4. 2 minus 5 is negative 3. And 4 minus negative 8 is the same as 4 plus 8, which is 12. Subtracting again on number 20. 8 minus 3 is 5. 6 minus 5 is 1. And negative 4 minus negative 8, which is the same as negative 4 plus 8, is 4. On number 21, we are multiplying a number times a matrix. All you have to do is multiply every number in that matrix by 5. So 5 times 2 is 10. 5 times negative 3 is negative 15. 5 times 0 is still 0. And 5 times 4 is 20. Okay, last section. Find the inverse of each of the following functions. So as long as you follow the steps for finding an inverse, you should be good on these. The first step is to change f of x to y. So, or any function notation. So we've got y equals negative x minus 5 over 3. Then we're going to switch the x and the y. So we've got x equals negative y minus 5 over 3. After you've done that, now you're just working to get this y by itself. So we need to first get rid of this fraction. To get rid of a fraction, you multiply both sides by the denominator. So 3 times x is 3x. The 3's cancel out over here and leave us with negative y minus 5. We can add 5 to both sides. So 3x plus 5 equals negative y. We want the variable that we're solving for to be positive. So to make this positive, we need to divide both sides by negative 1. You could leave it like this as a fraction, but dividing by negative 1, all it does is change the signs of everything. So instead of positive 3x, we have negative 3x. And instead of plus 5, we have minus 5. Once you've got y by itself, you need to change back to function notation. This time we're using function inverse notation. We've got f inverse of x equals negative 3x minus 5. So after you've got y by itself, you're done. You just have to change back to this notation. Number 23, same steps. We're changing the function notation, g of x, we're changing that to y. So y equals negative 1 minus 1/5 x. Switch the x and the y. X equals negative 1 minus 1/5 y. Then we work to get y by itself. So let's get rid of this minus 1 by adding 1 to both sides. So we get x plus 1 equals negative 1/5 y. And we need to get the y by itself by dividing both sides by negative 1/5. Okay, a little bit of scratch work. If you don't remember how to divide by a fraction, you keep the numerator, which is x plus 1. You change division to multiplication, and then you flip the bottom fraction. So instead of negative 1/5, we have negative 5 over 1. The sign stays the same, you're just flipping the fraction. So dividing by negative 1/5 is the same as multiplying by negative 5. So really we have negative 5 times x plus 1 equals y. If you leave it like this, I'm not going to count off. I'm going to go ahead and distribute the negative 5. So we get y equals negative 5x minus 5. Now we can change back to function notation. So this is g inverse of x, because the function we started with was g of x equals negative 5x minus 5. That was the hardest one, in my opinion. Number 24, change h of x to y and switch the x and the y. Those two steps should be done immediately, really without even thinking. Then we're going to work to get y by itself. So right now we have this minus 1. Let's get rid of that by adding 1 to both sides. X plus 1 equals 2y. Then to get y by itself, we just need to divide both sides by 2. So x plus 1 over 2 equals y. Could go further with this and say x over 2 plus 1/2. You could say 1/2 x plus 1/2. There's different ways that you could write this fraction, but I would just leave it like this. So I'm going to write my answer, h inverse of x equals x plus 1 over 2. You simplified it more than that, that's fine, as long as the math was correct. But you can definitely just leave it like this. Last one, k of x, change that to y. Then switch the x and the y. Okay, we're working to get the y by itself. Right now our y is being cubed, but we can't get rid of that yet because we have this plus 2 to worry about. It's not being cubed, so we couldn't just go straight to taking the cube root of both sides. We first need to get rid of this plus 2 by subtracting 2 from both sides. So x minus 2 equals y cubed. Now that the y cubed is the only thing on this side of the equal sign, we can get rid of that exponent by taking the cube root. If it were an exponent of 2, we would take the square root to get rid of it. If it were an exponent of 7, we would take the 7th root to get rid of it. It just corresponds to whatever exponent you have. So we can't really do anything with the square root of x minus 2, or sorry, cube root of x minus 2. So it's just going to stay the cube root of x minus 2. But then the cube root and the exponent of 3 cancel and just leave us with y. And that's it. We just need to change back to inverse notation. So k inverse of x equals the cube root of x minus 2.